Okay, so we're going to start talking about legacy code this week. And this is one of the big surprises, I think, when Dave and I started refactoring this course. And one of the things we did, like we said, is we went around to all the great software companies that try to hire our students and are some of the greatest places to work in the Valley if you want to do software that millions of people use. And we asked them what we needed to be doing differently. And the first couple of companies we talked to, like without even thinking about it, they said legacy code. Students didn't understand how to approach code that they did not write themselves and start adding value to it. And we, at the time, we didn't really have any thoughts about how we could teach that in a course. So we kind of assumed that those companies were wrong. And then we asked some more companies, and it turned out they all said the same thing. Like 6 of the top companies unanimously, the first thing they said was students didn't understand how to modify legacy code. So it finally dawned on us that we might have to figure out something about how to teach it. And I think we've managed to do a pretty good job of that. So I guess you all will be the judge. So we're going to talk about, we'll start with what is it that makes code legacy code, and how can the stuff that you already know about Agile help you in approaching it? And it turns out the answer is more than you think. So I'll frame the discussion in terms of, first of all, why you should care about this. We already knew from several earlier lectures that whether you come from the Agile side or the plan and document side, about 60 cents out of each dollar that goes into a software project really is spent on maintenance. So that's probably, by money, it's the most important part of the life cycle, right? It costs more to maintain software on an ongoing basis than it does to build it in the first place. And the saying is that old hardware just becomes obsolete. You eventually kind of move it along, you upgrade it. But old software is in production every day, as long as it's still solving somebody's problem. Robert Glass has been practicing software engineering for decades, and he's got this really great collection of very combative facts and fallacies. So that's where this one comes from. So motivated by this, we should be able to ask the question, how can we understand and modify legacy code in a safe manner? So let me just start with a straw poll. And those of you watching the video won't be able to see this. But by a show of hands in the class, how many of you have written legacy code? You have authored legacy code? OK, like 3 hands going up. OK, different question. How many of you have written code ever? Many hands go up. I submit that you have all written legacy code, because if you wrote that code more than like a month ago, it's legacy now. If you tried to go back to it and figure out what you were thinking when you wrote it, you probably don't know. So there's a lot. Legacy code becomes legacy really, really fast. And in keeping with the programmers or optimists, we always, well, it won't happen to me. I understand my code really well. You understand it today, right? Tomorrow, you probably will forget. As you get older, it gets worse. So the other thing to remember about legacy code is that when we think of software maintenance, we're like fixing bugs. That's actually, that's not necessarily true. Most of the maintenance cost is not in fixing bugs. It's actually in adding functionality, right? So if you're joining a software company and you're going to be put on a legacy code project, it doesn't mean that you're left to clean up somebody else's mess necessarily. It means you actually have to add value to something that probably is working fine, but for some reason it needs to work better. So we call it the 60-60 rule. So 60% of the money goes to maintenance, and of that amount, roughly 60% of that is on enhancements as opposed to on bug fixes. So what is it that makes code legacy? There's probably a few informal definitions that you're already familiar with. First of all, it still meets a customer need, because if it didn't meet the customer's need, we would just undeploy it, and then we'd throw it in the wastebasket, and we wouldn't have to worry about it anymore. So one thing is, well, I didn't write it. That makes it legacy code, and the documentation's not very good. This is legacy code. If it were my code, it would have perfect documentation, and/or I would know how to work with it. Or, well, it is my code, but I wrote it a long time ago, and, well, my documentation maybe was not everything it could have been. That's another version of legacy code. But I think the much better functional definition is the one that comes from Michael Feather's awesome book, Working Effectively with Legacy Code. And a lot of the treatment that we're doing of it in this class actually is inspired by the way that he approaches it. His view is if it lacks good tests, that makes it legacy code no matter who wrote it. And the reason for his statement is that you can really think about 2 philosophical approaches to how you would modify legacy code. The one that most people do, including myself, this is a time, today we're all going to sort of get in touch with our negative guilt feelings about our bad practices in software engineering. We're going to accept them, and then we're going to be empowered to do better. One way to think about legacy code is edit and pray. You make some changes. You're like, I don't think this broke anything. You try a few URLs. Nothing appears to be exploding. So you figure you're done. Or we could do it the more principled way, which is cover and modify, which means let good test coverage be your security blanket. If you've got a good test suite, then when you make changes that break something, your test suite should tip you off to that fact, because you'll have regression tests in place, or you'll know if you broke something. So this is kind of our goal, right? Our goal is to try to use cover and modify, the more principled way of doing legacy code, So how can Agile help us do it here? Let's think about legacy code in sort of two phases. In the first phase, your goal is to understand what the code actually does. So part of that is you have to get a good gestalt of the overall code base so you could figure out where you need to be making your changes. And just that phase actually takes a while. And in fact, we have an assignment coming up where you deal with legacy code. And it's divided exactly this way. The first part of the assignment really is mostly about identifying where you'd have to make changes in order to implement the new functionality that we're asking you for. And then the second step is refactoring. So is the code around the change points, right? The place where you have to make your own changes. There's two questions you can ask about it. Is that change point is the change point well covered by testing? And if not, is it testable? So even if the coverage is lacking, right? So you're in great shape if the code is already well tested, meaning that there's good coverage in the test suite. And remember that we're not relying on any one kind of test, right? Hopefully there's unit as well as functional and even some integration tests that touch that code path. So if the code already has good tests, then in some sense, a lot of the work is done for you. You'll know immediately if you start modifying it in a way that's broken. If it's not tested, but it's well factored, in other words, it's written in a way that the individual functions are short. Dave talked about running these different kinds of metrics to look at the quality of pieces of your code. If the code is generally in good shape, you might be able to backfill some of the tests. And now you have code that's testable, and now you can start from as if A was true. But if you have neither of those, which unfortunately is often the case, then you have to start refactoring. And this is where Agile can really help us. So how Agile can help? Well, we can add some tests to improve coverage, right, if the code is testable. We can make the changes, because now we have these tests that provide the ground truth, things that will go, fail, tests that will fail if we make bad changes. And then we keep refactoring to leave the code base a little bit better than we found it. So even after you've successfully made your changes, even after you have good test coverage for your changes, leave that part of the code a little bit better than you found it so that the next person who comes along behind you will have an easier time of it. And we've said all along that everything about Agile is about embracing change. This is like embracing change on longer time scales, right? So under this point of view, software, forgive me for the following analogy. Under this point of view, software is like cheese. It's alive the whole time until you throw it away. It's always evolving. You're always making changes to it. And you have to assume that you're never going to be the last person to touch that piece of code. So there's a good reason to leave it better than you found it, right? Organizationally, if it's your company that's doing this, it will save money and resources over the long term. By the way, I don't know if anybody knows the source of this quote. Try to leave the world a little better than you found it. Anybody? Anybody? Kids today? No? OK, this is Lord Baden-Powell. He founded the Boy Scouts of America. OK. Actually, the Boy Scouts of the UK, I suppose, on which the Boy Scouts of America was later modeled. OK, so with this in mind, let's do a quick sanity check to see where we are. If you've been assigned to modify legacy code, and I can assure you that unless you start your own startup, you are going to be assigned to modify someone else's code, which statement ought to make you happiest? That if someone's telling you about the code and they say, well, it was originally developed using Agile, or they say it's well covered by tests, or it's nicely structured and easy to read, or many of the original design documents are still available. We just have to look under the couch.